Alright, so I was looking at the weathering of basalt here, and it pretty much runs through what's happening. So it says that it weathers relatively rapidly because of its content. The minerals are less stable than like granite because of the colder, wetter environment at the Earth's surface than when it was magma. Blah blah blah. The finer grain size assists. High iron content causes weathered surfaces in human climates to accumulate thick crust of hematite, basically rust. Staining the rock rust red. Hey, imagine that. Because of low potassium, weathering converts basalt to calcium-rich clay rather than potassium-rich clay. Further weathering, particularly in tropical climates, converts that to kaolinite or gibbsite. This produces the distinctive tropical soil known as laterite. The ultimate weathering product is bauxite, the principal ore of aluminum. And then over here, yeah, blah 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 blah, it turns into calcite or calcium carbonate. So over here I was looking at the atomic weights and the molecular weights here. So this is optimistically the heaviest. I guess it could be like one heavier, because it could be Si3 and Al1. But yeah, so 5% optimistically, the most pretty much calcium you can get in your basalt is if it's 5% this, and most basalts are not going to be quite that rich. So the molecular weight of this guy is 278 roughly. I rounded. And the calcium is 40 of that. So that means that if that's 5% of your basalt by weight, then about 0.72% of the basalt is calcium by weight. And then if we convert this back, CaCO3 has a molecular weight of 100. So 2.5 times that of calcium, or we can just take this and multiply it by that 2.5, so 1.8% roughly the mass of the original basalt. And again, that is optimistic. It's probably lower than that. So 1 ton of basalt would yield just under 36 pounds. It's like 35.97 or some shit. 36 pounds of calcite at best. And then I had this from earlier, Tucson water hardness, and I kind of calculated out roughly, given my rain barrel size, how many gallons of water, how many barrels I would need to get a pound of limestone out of that, which is effectively the same chemical, calcium carbonate. And it turned out to sequester 1 pound of CO2, yeah, I would need 43 of those 30-gallon barrels. So then, unless I really fucked up the math, that brings us to around 6 tons of Tucson water. It contains enough calcium to produce 1 pound of calcite or limestone, or there's a whole shit ton of names for it, depending on how it forms. And this is roughly a half or 2/3 of the volume of the water used by my household in a month. So honestly, this is extremely accessible, 6 tons of water, because water is heavy. So this really isn't, seems like kind of a lot of water, but it's sort of not. Because my water bills basically do not change regardless of how much water I use. I use so little for a Tucson home. Yeah, so it's pretty much you'd have to run to get 1 pound of shell out of clams. I guess you'd have to run 6 tons of water. That does seem excessive at that point. And in comparison, just 1 ton of basalt will give you 36 pounds. So in that respect, basalt seems like it might be a little bit more efficient. But then I was looking around trying to figure out how long it takes to weather basalt down, and I found this. It doesn't answer that question, but it talks about some problems with this weathering of basalt. The second problem that it mentions is only a tiny fraction of ambient air is CO2, right, 0.04%, which also limits the speed of the weathering process. So they suggest that this can be mitigated by mixing the rock flour into farmland soil, which will considerably speed up the CO2 removal process because there's so much more CO2 in soil than in the air, usually 10 to 100 times more due to plants, roots, bacteria, etc. CO2 in ambient air is 415 ppm, while in soil it's between 400 and 40,000 parts per million. So, okay, think about what just happened here. They're obsessing about producing calcium carbonate now, CaCO3. They are not actually interested in taking CO2 out of the atmosphere, right? Because if the soil is holding up to 100 times more CO2 than the air, that means it always does that. It's always doing that. So pulling it out of the soil doesn't pull it out of the air. It's not going to go from the air into the soil now. You see what I'm saying? Like, they have failed to accomplish their mission because they're pulling CO2 from the wrong place now, right? So, right, it's there because of things like bacteria, which are respirating, and so they're taking in oxygen and they're producing CO2, and because CO2 is heavier than ambient air, it tends to fall, so it has a hard time getting out of the soil, right? Because it has to go up to get out of the soil. So anything that is relying on aerobic respiration is going to be increasing your CO2 level in the soil. Capturing that CO2 is not going to really have much of an effect on atmospheric CO2. You're pulling it from the wrong place. So, what? So, yeah, what we need to do is not do that, but actually get it to weather with atmospheric, ambient air, atmospheric CO2. So this is not a solution, and kind of everything I've seen talks about doing this. Wow, that's amazing. Nope, this is not going to be our solution. This is not going to do it. Yeah, distributing basalt, crushed basalt, this is not going to work. I'm pretty damn sure. And I guess the experiments are kind of in an early stage. But I'm really expecting that they're going to find that this does not work, because I don't see how this makes sense. And it does say that almost nobody has actually done this in practice or at scale, although there's lots of studies about it. And I'll bet you those studies, I haven't looked them up, but I'll bet you those studies, what they're doing is they're looking at whether they can increase the rate of production of calcium carbonate, which I'll bet you they can. I don't have a problem with that. I'll bet you what they're going to find, though, is that when they mix it into the soils, it does not have the effect that they thought it was going to, because it's not pulling it out of the air. It's just pulling it out of the soil. Which, yeah, that's going to help. That's going to help the aerobic bacteria. But what it's going to do is it's going to let them make more CO2. So this might end up having the opposite effect of what we want. We might end up getting What is this German bullshit? We might end up getting more CO2 production as a result of this, as well as the production of all of this calcium carbonate, as well as the production of all of the CO2 that went into the acquisition, crushing, transportation, and distribution of the basalt in the first place. So I really don't see this being a good... I hope I'm wrong, but I really don't see this working. I don't see this working at all. This looks like a bad idea.